Everything you see around you, the solid ground beneath your feet, the screen in your hands, the very atoms making up your eyes, began in a place of absolute, unimaginable chaos. We often look up at the night sky and perceive the stars as static, eternal, and peaceful points of light. But the universe is not a still photograph. It is a violent, roaring, and relentless factory. Right now, in the coldest and darkest corners of the void, millions of new suns are being forged in fires more intense than anything we can create on Earth. They are born from turbulence, from massive, suffocating clouds of dust and gas that we call cosmic nurseries. Have you ever wondered how total emptiness can create a giant ball of nuclear fire? How the cold ashes of dead stars become the seeds for a new era of life? Today, we are stepping into the heart of the most brilliant nebulae in existence to witness the most magnificent moment in all of creation, the birth of a star. Every star begins with nothing, or at least what our human eyes perceive as nothing. In the vast, lonely gaps between the existing stars lie what astronomers call giant molecular clouds. These are the titans of the cosmos, some of the largest structures in the universe, stretching for hundreds of light years in every direction. If you were to be transported into the center of one of these clouds, you would be shrouded in a darkness so total it would feel heavy against your skin. This is not the darkness of a moonless night on Earth. This is the darkness of a place where light itself has been strangled. The temperature here is bone-chilling, hovering just a few degrees above absolute zero, the theoretical limit where all atomic motion stops. You might ask, why does a star, a furnace of unimaginable heat, need extreme cold to begin its life? The answer is a beautiful irony of physics. Cold allows gas molecules, primarily hydrogen, to lose their energy and huddle together. When they are cold, they are slow. When they are slow, they are vulnerable. And that is when the universe's most patient and powerful predator strikes: gravity. For millions of years, gravity works in the shadows, silently pulling individual atoms of gas and microscopic grains of dust toward a common center. In the beginning, this movement is so subtle it is almost undetectable. But space is never truly still. Perhaps a shockwave from a dying star, a supernova, billions of miles away ripples through the cloud. Or perhaps two galaxies brush past each other in a cosmic dance. These events act like a spark in a forest of dry wood. Once the cloud begins to clump together, the process becomes an unstoppable avalanche. The cloud collapses under its own weight. As it shrinks, it begins to spin, following the law of conservation of angular momentum. Just like a figure skater pulling in their arms to rotate faster and faster until they become a blur. Imagine a region of space billions of times larger than our entire solar system, suddenly being compressed into a tiny, dense cocoon. This is no longer a cloud, it is a protostar. At this stage, the object is still dark, hidden behind a thick, swirling veil of dust that blocks all visible light. However, if you were to look through an infrared telescope, you would see a haunting, ghostly glow. At the heart of this spinning disk, the pressure is skyrocketing to levels that defy human mathematics. The temperature starts to climb, from the freezing depths of the void to thousands, then millions of degrees. The protostar is like a cosmic embryo, growing, feeding on the surrounding gas, and preparing for the moment that will change the universe forever. To become a real star, this embryo must pass a brutal, final test of physics. It is a threshold that separates the failed stars, the brown dwarfs, from the true suns. As the protostar continues to gather mass, the gravity at its core becomes so crushing that it forces atoms to do something they naturally hate. When the core temperature reaches a staggering, unthinkable 15 million degrees Celsius, the ignition occurs. This is the moment of nuclear fusion. At this exact temperature and pressure, hydrogen nuclei are crushed together so violently that they overcome their natural electromagnetic urge to repel each other. They fuse. They become helium. And in that process of fusion, a tiny fraction of their mass is converted into pure, raw energy. According to Einstein's famous equation, $E equals mc²2. In the blink of an eye, the darkness is shattered. The star cries, its way into existence with a glorious, blinding flash of radiation. This sudden burst of energy creates a powerful stellar wind, a gale of particles so strong it blows away the remaining dust cocoon, like a butterfly emerging from its chrysalis. A brand new sun is revealed, shining brightly in the vast, empty void for the first time. This is the most fragile and perfect balance in the universe. On one side, gravity is trying to crush the star inward, seeking to collapse it into a black hole. On the other side, the outward pressure from the nuclear fire in the core is pushing back, trying to explode the star outward. This epic tug-of-war will last for millions or even billions of years. It is this balance that keeps a star stable. It is this balance that provides the steady warmth and light necessary for life to take hold on a nearby planet. Without this perfect, high-stakes stalemate, we simply would not exist. But a star is rarely born alone. Cosmic nurseries like the Orion Nebula are not just producing one sun. They are churning out hundreds, even thousands, at once. Some are massive, blue giants that burn hot and fast, dying in violent explosions after only a few million years. Others are small, red dwarfs, frugal with their fuel, destined to flicker for trillions of years, long after every other light in the universe has gone out. And as these stars are born, they leave behind a legacy. Around the newborn sun, the leftovers of the gas and dust disk do not simply vanish. In that swirling disk, microscopic particles of rock and ice begin to collide. They stick together through static electricity, then through gravity, growing into pebbles, then boulders, and eventually into planets, moons, and asteroids. Every solar system is built from the scraps of the star's birth. The very ground you walk on is made of the dust that wasn't good enough to be part of the sun. Why do we spend so much of our time and resources staring at these distant, dusty nurseries through telescopes like James Webb? Because when we look at the pillars of creation, we aren't just looking at a beautiful picture. We are looking at our own history. 4.6 billion years ago, our sun was just a cold, weak protostar hidden deep inside an anonymous cloud of dust in a quiet corner of the Milky Way. Every element that defines your world, the oxygen you are inhaling right now, the iron that carries that oxygen through your veins, the silicon in the computer chips that run our lives, all of it was forged in the nuclear furnaces of stars that lived and died before our sun was even a spark. We are, quite literally, the recycled products of the cosmos. We are star stuff, as Carl Sagan famously said. When an old star dies, it doesn't just disappear. It explodes and scatters its enriched guts into the space between the stars. These elements eventually find their way into a new cosmic nursery, where they are gathered up to form a new generation of stars and planets. We are a part of this grand, eternal cycle of life, death, and rebirth on a scale so large it dwarfs human comprehension. The cosmos is not a dead, empty gallery of lights. It is a living, breathing entity, constantly reinventing and recycling itself. Every new star that ignites is a victory over the void. It is proof that even in the most frozen and desolate corners of space, light will always find a way to bloom out of the chaos. These cosmic nurseries are more than just birthplaces for suns. They are the cradles of every possibility, every dream, every scientific discovery, and every future civilization that has yet to rise. The next time you look up at the night sky and see the faint glow of a distant nebula, remember that you aren't looking at some alien or unreachable object. You are looking at your distant ancestors. You are looking at the great, ancient fires that forged the very existence of your soul. The universe is vast, cold, and often intimidating, but it is also filled with an incredible sense of hope and continuity. In the deepest, most terrifying shadows of those dust clouds, life is being prepared for the next billion years. The moment a star ignites is the universe's definitive answer to the silence of the void. It is a declaration that light will always conquer the dark, that if this journey into the heart of the cosmic nurseries has left you in awe of your own origins, hit the like button and share this story with someone who needs a reminder of how magnificent they truly are. What do you think about the fact that your body is made of recycled stardust? Does it make you feel small, or does it make you feel like you belong to something much larger? Let us know your thoughts in the comments below. Subscribe and turn on notifications to join us as we continue to explore the next chapters of this grand cosmic epic. Keep your curiosity burning as bright as those newborn suns, and never stop looking up. Thank you for watching, and thank you for being a part of this journey.